Okay, so today, September 19th, 2011, we're on lesson 1.3, which is actually page 20 in your textbook, okay? Now, on Friday, we covered quadrants and how to look at obtuse angles, angles that were past 90, 180, 270, and 360. So, just a quick recap. 180. We're just going to be dealing with up to 180 degrees today. When we draw degrees, what we're talking about is an angle that goes from 0 to 90. These are acute. And anything from 90 to 180 will be an obtuse angle. So, today we're working on actually solving angles in obtuse angles. So we'll take a look at our first example. Okay, so let's suppose we have an angle that is... Okay, so if we're dealing with an angle, let's say that is 123 degrees. Okay, so that means this is an angle that is greater than 90. 90 is just straight up and down. This one goes past 90. What we used before won't work on obtuse angles, our trig ratios. Okay, so we have a triangle. It looks roughly like this. I'm going to tell you that this is 123 degrees, and I'm going to tell you how we would have solved it before. So, what I want us to set up is if we have a triangle like that, what we're looking for is the flat end of the triangle to go here on the graph, and then to come out to here, finally like this. So if you guys notice, we have 123 degrees. This would be the angle of the inside one. Now, normally what's going to be happening is you guys are going to be solving for that angle. What I want you guys to recognize is in order to solve for that angle, we have to create a right angle triangle. And in order to do that, we set this triangle up on our graph, and then from there we create a right angle. So our right angle is actually over here. And this is our right angle triangle. So I'm going to put just dashes on parts of the triangle. This is the triangle we're going to use in order to solve this angle. And again, I know that I've already given you the measurement, but normally we'll be solving for that angle. You guys will have to set up triangles like this. Okay? And what's important to realize is this will be the hypotenuse of the triangle. And then we'll be looking for this angle here. Once I have this angle here, how can I use it to solve this angle? Subtract from what? That's right. This flat line is 180 degrees. So once I have the measurement of this angle in here, I would subtract that amount. So let's call it, let's say A. I would subtract that amount in order to find out what this angle is here. All right, we're going to write down some of the properties of supplementary angles. A supplementary angle are two angles that create 180 degrees. So, like we just did before, we had an angle that was 123. We had an angle that was 123. And what would the other part of this angle have been? That's right, 57. Good. So, these two angles together are supplementary angles. They create 180 degrees. We're going to go over some of the rules and properties of that. So, very first one, given an acute angle, its supplementary obtuse angle will look like this. So, our formula in the book, and they've given you this on page 22, is 180 degrees. Subtract your acute angle, which we already know. We know to find our acute angle, to find our obtuse angle, we take 180 degrees and we subtract the acute angle we've already found. So, the three properties, well, if we had sine, the acute angle is equal to sine 180 degrees, subtract that same angle. Cosine of the acute angle is negative cos 180 degrees of A. and tangent of the acute angle is negative tangent 180 subtract A. Now, from what we did on Friday, why do I have cos and tangent as negative numbers? Does anyone remember? Yes, Sampras.
Because quad 2 is, quad 1 is all positive, quad 2 is sine positive, and the rest negative.
Good. Okay, so on Friday we went over the cast system. We had C, A, S, T. And what that told us is of our 4 quadrants, quadrant 1, 2, 3, and quadrant 4, it told us which of the trig ratios are positive. So we figured out since this is A, that means sine, cos, and tangent are all positive in this quadrant. This was S. So this meant only sine ratio was positive in this quadrant. Cosine and tangent are both negative, which is exactly what we see here when we set up our formula. Okay? And from here, this was tangent was positive, and this was cosine was positive. But because we're working with obtuse angles, we're specifically working in quadrant 2. So in quadrant 2, when we set up a sine ratio, we know that sine will be positive. We would take our acute angle, which we had before from the triangle, and we would subtract 180 from it in order to find our obtuse angle. If we had a cos ratio, we do negative cosine, and if we had a tangent ratio in here, we do negative tangent. Okay, so let's say we're looking for our obtuse angle. We've put our triangle into our graph, and we created a right angle triangle in the second quadrant. It's very important that you guys realize this right angle triangle is the only time we can use our sine x is equal to opposite over hypotenuse, cos x is adjacent over hypotenuse, and tangent x is opposite over adjacent. We can only use those ratios because we have set up a right angle triangle. I would not be able to use those ratios on this. So if I had, say, a measurement of 15 and 6, and I needed to find out this angle here, I can't use these ratios because this is not a right angle triangle. These ratios only work on right angle triangles. That's why we set up this right angle triangle here in order to solve for the obtuse angle of this triangle. So what we're going to do is I'm going to start off actually a little simpler, and instead of solving right off the bat, I'm going to tell you one of them. So let's say we have, it's too much. Let's say we've discovered that we're using our sine ratio, and it's of an angle P, so this is unrelated to above. Actually, I'll put it on. So we're looking for sine. We're going to use sine ratio. And we have the measurement of an acute angle. The measurement we've discovered is 0.65. Okay? So we're going to need to solve this. So when I set this up, I say that sine of angle P is equal to 0.65. Now, in order to get that 0.65, I've divided two numbers already. Okay? I've already discovered that the opposite side divided by the hypotenuse was equal to 0.65. So let's say that the opposite was 65 meters long and the hypotenuse was 100 meters. So we can even refer that to this triangle here. So let's say we've already discovered that this was 65, this measurement was 100, and we're looking for this angle. Because it's that angle, we put our opposite over our hypotenuse. So when I've set that up, 65 divided by 100 gives me 0.65. Okay? Now this is what I want you guys to focus on. Don't worry too much about what I've done over here. We're going to focus on just solving this right now. In order to solve for angle P, which remember is the acute angle in the triangle, I need to move sine to the other side of the equation. In order to do that, in order to do that, sine goes to the exponent of negative 1, 0.65. Okay? Now remember, we did this on Thursday. In order to solve that, we're going to have to probably put shift in our calculator. So, I'm going to put in 0.65, and I'm not using my sine. I'm going to be using sine to the power of negative 1. When I hit that, I discover that my angle is 40.5. So, angle P is 40.5 degrees. When we go back to look at this angle here in red is 40.5 degrees. Now, that only gives me the acute measurement. It hasn't told me the obtuse. So, in order to find the obtuse, I'm going to take that measurement there, subtract 180 degrees, and we end up with 139.5 degrees. So, after all that work, we've discovered that this angle here, the obtuse one, is 139.5 degrees. That's the inside angle there. So, again, to recap, in order to solve this obtuse angle, we needed to solve for the acute angle in our right angle triangle. Okay, so I'm only going to give you homework that pertains to starting from here down. So you guys will not need to set up these triangles today. Okay? All you'll have to do is work on setting up acute measurements. So, an example of a question might be something like this again. They might tell you that the cosine of an acute angle R is 0.22. You guys have to go and use these ratios down here. Okay? You need to use cosine of A is equal to negative cos 180 minus A. So you need to set up your ratios like that. Okay? So all the homework will just be given you. They've already put your sine together. You guys just need to set it up in an equation. So we'd end up with cos of angle R is equal to 0.22. And you guys will be moving cos to the other side and then figuring out what the obtuse angle is.
There's like something spray painted on the roof of your car.
Okay, so your homework today, page 23, numbers 1, 2, 4 to 6. Work on that. This video will be up tonight.